Hey guys, this is Miss Carlson, and I'm going to go over with you your Chapter 1.3 and 1.4 measurements and organizing data notes. So please make sure you have your paper either set up for taking good Cornell notes or you have a Cornell note template. And let's go ahead and get started. We're going to start off with measurements, and this information can be found in section 1.3 of your textbook. And length is a measurement we're going to be working with quite often. It is the distance of a path between 2 points. The primary unit of measurement is going to be the meter. And then you'll need to know that 100 centimeters comprise 1 meter. 10 millimeters comprises 1 centimeter. And then if we had 1,000 meters, that would be a kilometer. Now those prefixes, kilo and centi, those are going to go across the board for any quantity we use. They're going to mean the same thing, and we'll kind of get into that as we go along. All right, here is a universe, and it is 6 times 10 to the 18th miles long, okay, in length. That's a very, very big number. Or we could say it's 1 times 10 to the 21st kilometers, again, and it shows you the actual number here as well, which is actually equal to 1 zentimeter. So, a very big number if you've never heard of a zentimeter. Now, notice that these are in scientific notation, and this would be in standard notation. Okay, and we will be working with scientific notation in class and some practice on how to take these numbers and work with them so it makes our lives a little easier. Now on the other spectrum, something very, very small would be like an animal cell. It is only 1/100th of a millimeter. That is very tiny, so that gives you a good reference on length of very, very big versus very, very small. Okay, moving on to mass. Mass is another measurement we're going to be working with quite a bit, and it is the amount of matter in an object. It's associated with weight, but it takes out gravity. Okay, so mass is just the amount of matter without the gravity added to it. Otherwise, that would be your weight. The primary unit, again, we have the gram. That's our base unit, and then if we add those prefixes, milligrams. Okay, there's 1,000 milligrams in 1 gram, so that means milligrams are smaller than a gram. And then we have the complete opposite spectrum. There are 1,000 grams in 1 kilogram. Again, that kilo prefix means 1,000 times. And we would use kilograms for the mass of the Earth because it's very, very large. And here you have the scientific notation again for in kilograms, 5.9742 times 10 to the 24th kilograms, or what is known as 5.0742 yottameters. Again, probably an unfamiliar unit of measurement that we're not going to use very often, but kind of cool to know. And then you have a tiny, tiny little ant, and its mass is 1/10 of a gram. So again, pretty broad range spectrum for mass. Okay, the last main measurement we're going to work with is volume. This is about a space that something takes up. Like if you were to pour liquid into a cup, the amount of space that it takes up is its volume. If it's a solid object, that volume is normally going to be measured in cubic centimeters. Okay, if it is a liquid, we usually measure in milliliters. So here is the common unit, like I said, centimeters cubed, or cubic centimeters for a solid. And to find the volume of an object, there are 2 different methods. Cubes, measuring length times width times height, again, if you have a solid object. Irregular shapes that are solid, you can actually drop into a graduated cylinder and measure the displaced water and subtract that from the original amount of water. This is called, and I'll go ahead and let you take a guess. If you said volume displacement, you are correct. Okay, so 1 milliliter is equal to 1 cubic centimeter. Like I said, we'll use milliliters for liquids more often and centimeters cubed for solids. Here we have a giant body of water, about 1.3 times 10 to the 9th kilometers cubed, okay, or 1.3 cubic gigameters. That's the volume or the amount of space a possible ocean could take up, very, very much space. And then if you take the volume of a stomach, if you have a mouse's stomach, 1 centimeters cubed. That's very, very tiny volume for a mouse, and it makes sense because mice are small. Humans can have 2,000 to 4,000 centimeters cubed space or volume that can be filled up in their stomachs. And again, it makes sense because we eat a lot of food. Alright, now we're going to move on to section 1.4, organizing your data. Again, not a whole lot of surprises here. Data tables and graphs are what we use to collect and analyze data, especially when using the scientific method to solve a problem. So a data table right here is an example, average annual precipitation for selected U.S. city. So you should notice that every data table has a title, and there's a title for the independent variable, and a title for the dependent variable, including units. This one doesn't really lend itself to having units, but usually you want to have a unit for each label. And then here is a graph. Okay, again, notice all good graphs have a title. They have units and labels on each variable. Okay, so you have your independent variable here, on each axis I should say, and your dependent variable here. And notice we have equal intervals across the board. We don't skip 2's in places and skip 1's, or skip 2 squares here and then 1 square there. It's got to be equal intervals. And they have a best fit line, a line drawn through most of its points. Now another thing this graph is pointing out is how to get slope. We will start working with the slope equation, not as much this semester, but definitely second semester. And so it's good to know that slope is the rise over the run, which is really just taking your x values over your y values between 2 points. So if I got my little tool here, and I do, so this over here, your rise is your y2, so your second y value minus your first y value, over your x2 value minus your x1 value. Once you subtract those values, which again you'll find over here, this point and this point for y1 and y2, and then for the x's are right here, your run, the distance between these 2 points. You would divide and get your answer for your slope. Alright, moving on. There are other 2 types of graphs you might make, a bar graph versus maybe a pie graph. Bar graphs are good if you're showing comparisons between things and just to generally see the numbers. Pie graphs are used to get a relationship amongst certain items. Like this one is composition of Earth's crust. So you can very quickly see that the majority of the Earth's crust is filled with oxygen. Okay, so both of these are good. We'll probably use line graphs the majority of the time, and they show patterns very easily. Alright, and you're all set. That's the end of your chapter 1.3 and 1.4 video notes. Please go back and replay anything that you need to see again or think that you need to have more time to copy, and I'll see you tomorrow.